Let's do practice on for loops. Remember the special sum homework where when we should read t test cases, and for every test case we read a single number, for example 3, and then for the 3 integers that we read we need to do special sum. We're going to sum the first number like plus the second number to the power 2, the third number to the power 3, the fourth number to the power 4, and so on. So the kth number is just repeated k times. We would like to repeat all of this sum, something like 1 2 3 4, 1 once, 2 twice, 3 3 times, 4 4 times, and so on. We already did this homework in the hard section, and today we'd like to see how well this code can be handled using for loops. Give a try. Let's see how can we do that. So we first of all switch the while loop over the total test cases with the for loop over test cases. This way we got rid of many lines for the while loops. After that we are going to read the n and convert it to integer here, and also initialize the sum to 0. And then our second loop will be iterating n iterations over the n itself. So again, for position over range n will be enough. And then we're going to read the next item, cast it to integer, and initialize the result to 1, not to 0. After that, we would like to compute the current element, but to the power of position plus 1. Why plus 1? Because I started this range from 0. If you started this range from 1 to n plus 1, then you don't need to put the plus 1. It's up to you. So this third loop here is just doing this power thing. That's all. As you see, overall the for loops made our code is much more convenient. If we would like to replace this for loop with the Python power operator, then it just be sum plus equal value to the power position plus 1. Yeah, that's all. Let's move to two challenging problems. We will read 3 integers n and m and the sum, and we would like to find the total number of a and b pairs that satisfy the following: a plus b equal sum. And the condition is a is a number that should be between 1 and n, and b should be a number between 1 and m. We would like to find the total number of a's and b's that satisfy these 3 conditions: a 1 to n, b 1 to m range, and every a plus b equal the target sum that we have. Try to stop the video and code it. Here is one test case to verify your output, and after you solve it, I would like to try this big test case. So this problem can be solved with a nested for loops. We are going to read the 3 integers here, and then we will for loop over I, which is corresponding now to the a, from 1 to n plus 1, which is 1 to n, and the j from 1 to m. Now we satisfied these 2 conditions. The third condition is to make sure that the a plus b equal the sum, so we are verifying that here with I plus j equal sum. If this is true, we count a plus 1. So far so good, so straightforward. The problem is if you entered such a big test, such an input, this program is going to work like very huge number of operations. So I would like you to try to think in a very simple math trick that can help us to remove this for loop in the 7th line. Like, we don't need it actually, it's just very trivial for loop. Okay, so the idea is the second loop was useless, as only maximum one of the j's in this for loop will match the sum, and all of the other values are useless. With some simple math, we can know the possible value of j. Then just we verified it. Try to again try to stop the video and make use of this hint. Here is the code. There is only one j that could be possible. We know from the equation that I plus j equal sum. Then if we have the I and we have already the sum, we can do simple math, and then j is sum minus I. So we know exactly which j is correct. The remaining step is to verify that the j satisfies the condition, which is being between 1 and m. If it verifies that 1, is going to take to be just just add 1 for that here. Now thinking about this code for an input of n, some n, like let's say 1000 or so, is going to take around 3 n steps. Okay, so this 3 isn't big idea here, like, but overall it is linear in the number of n. Take 3 n steps, 4 n steps, something around that. But this code here, it takes for an input n some constant times n square, or specifically, like we have n steps here and m steps here, so it seems we have n times m steps times some minor factor, maybe 6n times m steps. So if you entered 1 million and 1 million, this code is going to be like maybe 3 times 1 million squared. This is a lot. Let's move to another challenge, very similar idea to the previous one. We will read 3 integers n, m, and w, and we would like to find the total number of triples a, b, c such that a plus b is less than or equal c, a from 1 to n, b from a to m, and c from 1 to w. Again, this is a valid test case. Try to stop the video, make it first the slow way, and then let's think about the fast way. The slow way will follow the same trend. Let's make a for loop of I, j, and k. The I from 1 to n, and then this guy from I to m, this is the I, and this guy from 1 to w. And then we put the condition, if I plus j less than or k, then we can count plus 1. Now, to make it faster, we can remove the line in the for loop in line 8. So try to think about that. Exactly the same trick, but just one minor change. In the previous one, we needed to say I plus j equal k. Now it is like I plus j is less than or equal k. Here it was just one valid value, but here it seems more than one valid value. Still, the math is easy. If we like, let's say that we have k equal 4 and w equal 7, and let's say that this k is valid 1, then all of the valid numbers should be the complete remaining numbers, which would be 4 and 5 and 6 and 7 here. So the remaining numbers would be w minus k plus 1. So we move over I and move over j, and get our first k here, and then the remaining of k till the end of the range are all valid numbers. So try to think about this test case if you are a bit confused. That's all.